So this window, it's definitely British. I can't remember where it says Oasis Academy. I'm too lazy to look up where that's from. Maybe Winteringham. So good job, people at Winteringham. Thank you for making this. Okay, so they're talking about exploded drawings, right? The idea of like this Lego dude. Is that a student, you think? Probably. He's wearing like a beret. So it's just a way of showing the components that go into an object in parts. So we think like IKEA assembly drawings. IKEA is a bit of a sensitive issue at the moment in our household. Okay, so what is an exploded drawing and why are they needed? So an exploded drawing is a drawing that shows, well, here we go, the intended assembly of a product. It shows all parts of the assembly and how they fit together. Yeah, they give the viewer a good understanding of the components and the proper assembly of those things. Okay, the next thing we're going to talk about is section views, and section views are really important, right? So what a section view is if we cut things in half. So we saw in the two drawings we did today hidden detail, but really engineers get a lot more information by showing things in a section. If I drew this apple with a bunch of dotted lines to say, well, there's a core and there's seeds, it would be very, very confusing. Where it's much, much easier to understand what's happening inside an apple if you just provide a section. The same thing with this capsicum, right? Way easier to understand what's going on, and that's generally the way we approach things. Is that we can give a lot more information about an object if we provide multiple views where one of them is a section view. Okay. They have some questions. What is a section plane? Okay, sectional view cuts along an object along a plane, allowing you to see the internal details. Yep, that's a pretty good answer. What convention do you use to show a solid surface on your sectional view? Well, we should use hatching is the answer. They don't seem to say that. They don't give the answer anyway. So to show that this is solid, right? To show this is solid, we use these lines here, which we call hatching. Well, we sometimes call that sectioning, but yeah, hatching is the term. And that shows us that the material that we've cut through here is solid, that we're not looking at a void. Whereas where there's no sectioning, that's showing us that there's some sort of void happening there. So like in these objects here, they want to differentiate between a section view and a cutaway view. A cutaway view is when we have something that's like isometric drawings. We'll always use orthogonal drawings that are sectioned. And so here we can see that this material here is solid and the rest of this is hollow. So that makes sense when we look at the cutaway view. Okay. Okay, now different views that we use. Negative. Oh well. You'll be pleased to know I don't have COVID, everybody. Yeah. And you might hear a few minutes of microwaving, but we're at the end of this recording. Okay, so we should be familiar with third angle or orthogonal drawings. Now, it's important when we're looking at these sorts of drawings that Australia uses third angle. The symbol for third angle, I think of it as that we have the target and the flag. Actually, what we're drawing is a picture of like this cone, and that if we draw a cone in third angle projection, we'll get something that looks like these two concentric circles, which I call the target, and this trapezium, which I call the flag, just because it gives me words to use. I also chose those words because target starts with T, like third starts with T, and flag starts with F, like first starts with F. So if we're saying third angle, we have T first. If we draw this the other way around, I will remind you that in third angle projection, we always draw this like a less than symbol, right? So that helps you to remember which way the flag goes. Okay. Practice task: draw the third angle third angle orthographic symbol using drawing conventions. Copy and complete this thing. They want you to draw this thing here. Okay. Oh, they want, yeah, this thing, this bracket. Yeah, it's a task. We've done lots of tasks, so we don't need to worry about it. I've tried to avoid circles too much so far, but okay. Last we have isometric drawings. Isometric drawings match the orthogonal projection. Okay, that's the task. Not a whole lot of information here. So isometric drawings, look, I say not a whole lot of information. Okay, so we have, with a orthogonal projection, these lines are always drawn 30 degrees from the axis. We talked about axiomatic, where architects, they draw at 45 degrees. Looks horrible in my opinion, but that is a common convention for architects. They produce relatively realistic drawings, not as realistic as perspective, but they do look much more natural than oblique drawings do. They have the advantage that all the dimensions can be drawn accurately off the all the dimensions can be measured off the drawing, which is important. This shape here that we usually use to start is called a crow's foot, and that's where we start. So it says step 1, draw the crow's foot. Step 2, extend out until we have all the dimensions we have. Then draw a box, box in the object, and then you can start filling in the box from there. Now the thing that is both both the most difficult but also the most useful part of these drawings is what we call isometric drawings. And here we have a 6-step process on how to draw isometric drawings. I have a link to a YouTube video that tells you how to do that, and I find that can be more useful. Okay, last week we were going to talk about line types. Now, how are we doing for time? Yeah, still got 9 minutes, doing great. Okay, we have leaders and center lines and dimension lines. So here's where I saw chain dimensions, right? So you shouldn't have multiple dimensions off the same spot. You should have nested dimensions. Nested like nesting dolls, those Russian dolls where you have one fits inside the other. That sort of idea. The idea of you don't want to have multiple chain dimensions is because I think that it makes it hard. It makes it a lot more likely that someone's going to make a mistake. So you want to reduce the opportunity for people to make mistakes, because even if your drawing is correct, it's still no one wants the loss of time. Even if you sue the person, you're never going to be happy about it. Okay, so I don't know why it says important dimension. Anyway. We have some specific things we're going to learn more about later, right? So we have holes with a counterbore, where it tells us that, and I think that if you think about this kind of intuitively, we'll think, okay, we're going to draw 8 diameter. This is the diameter symbol. 8 diameter hole. It's a through hole, which means you drill all the way through, right? There's 3 holes and blind holes. A blind hole is where you don't drill all the way down. So the hole only goes a certain depth. You can't look through it. And then there's this symbol, which is the spot face hole. And it says the spot face hole is 13 millimeters and it goes down 8.5 millimeters. That's what they're saying there. There have been questions that have asked you to specifically know the order that we write this. I think that's sort of, that's sort of the sort of trivia that when Einstein talks about how, people shouldn't bother worrying about facts that can be looked up. They should be worried more about concepts. Now, leader lines are when we want to talk about things, and so we're not going to dimension that. We're going to draw these lines. Now, typically, we want to draw these lines, so we want to draw them at a steep angle. See how both of these cases, we draw them at, I would draw them at an angle other than 45 if it were me. 30 and 60 is ideal, but if you can't do that, then you draw it at some angle. They should always point to the center of the object you're referring to. So even though this is a diameter, the diameter should always point to the center of the diameter. And then you turn the line at, ideally you want to turn it to horizontal. And that just helps people to know that this is a dimensioning tool, not something that is part of the drawing intrinsically. So we will talk more about dimensioning circles later. I have some pictures on that. Anyway, so center lines, there's a standard to show. Center line typically shows us that things have rotational symmetry. So things like spheres or cylinders, that sort of stuff. Okay, what are their other clues? They say avoid dimensioning hidden detail. That's fine. Place dimensions where the shape is seen best. Avoid dimensionings on the object. Select one size. Yeah, no more than 2 can be chained. Yeah. Well, you know how I feel about that rule. Okay, I'm less worried about that when using AutoCAD, and the reason for that is because although the reader might make a mistake, it's less likely that you're going to make a mistake when using AutoCAD. And it's also true that when you send an image to someone in AutoCAD, if they want, they can measure directly off the drawing using the DI tool that you saw me use. Okay, so when we're showing our object, it should be done in heavy lines. Section lines, like the hatching that we saw earlier, should be thin light lines. Hidden detail should be a thick dark line. Center lines are thin. Dimensioning is thin. Cutting planes, yeah, that's not how we draw a cutting plane under Australian standards. There's also something called break lines, and break lines show that I can't be bothered showing the whole object. So I'm going to cut the object at a certain distance. Unfortunately, they don't seem to have an example anywhere here where they've used a break line. So we might look at the Australian standard drawing quickly to talk about that. Let's see. Hopefully I have my drawing standards document open. When I say my drawing standards document, it's just a bunch of stuff that I've taken. Okay, so this is where they show break lines. This is the standard for break lines. So with dashed lines, I think they do specify what distances somewhere with S and Q. I can't be bothered looking up where S and Q are. That might be in the next page of this document. So dimensioning, oh yeah, it should be 2.5. I take that back. I think I said earlier 3.5. That's for subtitles and headings, not for drawing titles. So yeah, 2.5. We'll note that next time. Better to be right at some point in the video. Take that, comments. It'd be nice if I could just see something that had a break line in the book. No. We'll just Google it. Technical drawings. Okay, so for pipes, the standard for drawing break lines is, I would say, or cylindrical objects, you draw this. So if it's a solid object that you don't want to bother showing the whole thing, what you can do is you can, so they say a short break should be thick and dark like this. A long break should be thin with these lines. A cylindrical break should be shown like this. And this should be hatched to show the object as being solid. Or if it's a pipe, you'll have a gap in between. Something like that. This section here should still be, part should still be sectioned though. It'd be nice if we could see a functional example. Well, okay, this is not a bad example. Yeah, and this here is not bad. I think the HSC the last year maybe had one. If we don't want to section the whole thing, we can put a break line in the section, and we just draw that as a squiggly line. Yeah, this one's good. Okay. So, copy image address. So, if we don't want to show the entirety of this object, so we can put break lines just to show that we don't, it keeps on going, but we can't show the whole thing, we can't fit the whole thing on here. So here we've got some pipes. This drawing here I think is actually looks a little bit better. It's a threaded pipe, and they're trying to show that we can't fit the whole pipe on the drawing. Right? That was the break in copy image. Yeah, so that's it there. So we've got some break lines. So we don't want to show the whole object. So we don't want to hatch the whole object, so we can just show the part that we're interested in. It's also worth pointing out that you do get used to looking at objects in, I guess this is a half sectional view. So sometimes we only want to remove 1/4 of the apple. And so that we show the full apple on one side. I probably wouldn't have shown, this is a coffee cup in this case, I wouldn't have shown the hidden detail if it were me, because we don't want to really combine hidden detail or not, and sectioning, sorry. So, some good stuff there. Thanks, MH High School. Yeah, some more break lines. I think we've got the point at this point, and we're now at 10 o'clock. Yeah, that'll do. Okay.